As you understand, the most important component of the reverse osmosis process is the membrane. Today, the most widely used type of RO membrane is a polyamide thin film composite. It consists of 3 layers: a semi-permeable thin layer that is less than 0.2 micron, 200 nanometers or less. It's made of aromatic polyamide, which is supported by 2 layers. One is microporous polysulfone layer. It's about 30 to 40 microns. That is cast on top of the reinforcing layer of polyester fabric. It varies around 100 microns. The ultra-thin polymeric film is the feature that gives the RO membrane its salt rejection abilities and all other characteristics. The main functions of the 2 support layers are to reinforce the membrane structure and to maintain membrane integrity and durability. The most widely used membrane module configuration today is a spiral wound element, as it is shown here. It consists of a number of so-called envelopes. Each envelope is basically 2 membrane sheets separated by a thin plastic net that is called a permeate spacer or permeate trico that forms a channel that allows transport of the permeate towards the permeate tube collector. The membrane leaves are separated by a feed spacer which forms the feed channels and provides the mixing of the feed stream along the length of the membrane element. The whole assembly of envelopes is rolled around the perforated permeate collector tube and collected by a fiberglass shell, covered by the fiberglass shell. The 2 ends of each RO elements are finished with plastic caps that we call end caps or anti-telescoping devices. There are several ways to classify RO membranes. One of them shown here. It depends on the water source of the application. In general, membranes can be divided into seawater and brackish water membranes, depending on the feed water salinity. Here in the table, you can see very approximate brackets for each membrane. For example, for seawater membranes, the salinity of the water varies from 35,000 milligrams per liter and up. These membranes can operate at pressure up to 80 bars. Brackish water membranes are designed to treat lower salinity, anything below 10,000 milligrams per liter. And within this classification, there are subsets of membranes that are rated for different performance. For example, within seawater domain, we can differentiate high rejection and low energy membranes. Same we can do in the brackish water membranes. As the name suggests, low energy membranes are designed to reduce the energy required to generate permeate, while high rejection membranes offer better permeate quality at the expense of the energy savings. Other types of membranes available on the market today are low fouling membranes and low differential pressure membranes. Low fouling membranes reduce the potential for fouling, and for example, by changing the surface properties of the membrane layer or the polyamide layer. Low differential pressure membranes can be considered as a subset of low fouling membranes. These membrane modules typically have a special feed spacer with optimized geometry that leads to lower pressure drop performance. The feed channels will not plug as quickly with the suspended solids, foulants, or scale. Today, LG Chem produces the full line of seawater and brackish water thin film nanocomposite reverse osmosis membranes that can be selected for various applications. We can offer the highest rejection seawater membranes in the market, so-called G2 membranes, with 99.89% rejection, and the broad spectrum of brackish water membranes, varying from high rejection membranes with the rejection 99.78% and anti-fouling membranes to a low and ultra-low pressure membranes. For details, you can go to our website and see all the specifications. For a system designer, it is important to choose the right set of membranes for a particular application. It requires certain experience, of course, but as a very basic set of guidelines, you may want to use this chart. The upper row shows the range of seawater membranes, while the lower row it's for brackish membranes. If you're looking for energy savings, then your choice is the ES membrane. If you do not have very tight requirements for the product quality, or your application temperature is relatively low, let's say because below 25 degrees C, then again your choice is ES membrane. If you need a high quality product with low TDS, or your feed salinity is high, let's say it's somewhere in the Middle East, then your choice is high rejection membranes. For seawater, it can vary from relatively energy efficiency friendly R to very tight SR membrane. For even better quality or some energy savings, you may want to consider premium G2 membranes. For brackish water applications, the choice is even wider. In addition to high rejection R and RG2 membranes, we offer ultra-durable Dura membrane and anti-fouling AFR membranes for challenging waters. Again, if you have any questions regarding the choice of a particular membrane for your application, do not hesitate to contact LG, to contact us.